Welcome back to another episode of Tech Unplugged, the podcast where we break down complex tech topics into bite-sized bits. I'm your host, Your Name, and today we're diving into the fascinating world of PCIe communication, particularly focusing on implementing a PCIe endpoint on Xilinx 7 series FPGAs. Now don't worry if you're not a hardware engineer, I'll walk you through it. To kick things off, let's talk about what PCIe actually is. Essentially, PCIe, or Peripheral Component Interconnect Express, is a high-speed interface standard that allows various components of a computer or device to communicate with each other. Think of it like the information superhighway within your device, sort of like connecting different cities with high-speed trains. Today, we'll be exploring how developers can use the hard block of PCIe 2.1 and the GTP transceivers in Xilinx FPGAs, specifically the 7 series. Now, a technical document might sound dry at first, but there are some real gems in the details. For instance, did you know that this setup completely avoids proprietary Vivado IP cores? This makes it highly compatible with open-source projects like OpenXC7. It's like having a traffic-free route. This means developers can create robust designs while remaining flexible and open to innovation. Jumping into the specifics, one of the exciting parts is the clock structure. The design utilizes a module called pipeclock.v to generate all necessary clocks needed for PCIe operations. I can almost hear your brain whirring as you ponder what exactly clock structures mean in this context. In simple terms, clocks in FPGAs ensure that data moves at just the right pace, kind of like a conductor leading an orchestra. For example, the PCIe reference clock operates at 100 MHz, which is crucial for synchronization. Isn't it cool how these tiny details drive performance? Now let's transition into how the different modules work together. You have something known as the pipe wrapper.v, which contains the GTP transceiver. Imagine this as the central hub where all the connections happen. It interacts via the pipe interface with the PCIe 2.1 hard block. This modular structure seems complex, but it effectively separates different tasks, much like how different departments in a company focus on varying projects. We also need to highlight the note on supported modes. This setup accommodates PCIe Gen 1 and Gen 2 connections. This compatibility opens doors for various applications. Just think about it, using the Xilinx AC7100B SOM or the Wavelet USDR to enhance performance. It's similar to upgrading your phone. You get more features and improved speed without starting from scratch. Now, if you're feeling inspired and want to get your hands dirty, there's a simple command to kickstart your project using Docker. It's as straightforward as clicking Start on a video game. Just run the command and you're off to the races. But wait, before we wrap up, we should touch on the funding behind this project. It's supported through NGI Zero and Trust, with backing from the European Commission's Next Generation Internet program. It's a great reminder of how funding from initiatives like these helps propel tech advancements. So to summarize, today we've uncovered the modular beauty of implementing PCIe on Xilinx FPGAs, the elegant clock structure keeping everything in sync, and the fascinating open-source angle that gives developers flexibility. Before we sign off, I'd love to leave you with this thought. How do you see open-source technologies shaping the future of hardware development? Let us know your thoughts. Thank you for tuning in to Tech Unplugged. Join us next time as we continue to explore the connections that inspire and innovate the tech world. Until then, stay curious.